extended Euclidean algorithm is good not only for finding the greatest common divisor of two numbers, but also it will giving us the linear combination of those two numbers to get the greatest common divisor. So let's say if the given two numbers are 2632 and 1009, then if you just apply this algorithm, it shows 1 should be the greatest common divisor of these two numbers, which means there is no common divisor except 1, and the linear combination of those two numbers with these results will giving us the greatest common divisor 1. Of course, in our lecture note, I already mentioned that there are infinitely many different possibilities to find these two numbers, but this will giving us one of them. Okay, let me explain how it's going to work. Let's say these two numbers are given, then we place those two numbers in descending order, so greater number and small number like that, and 1001 is given in this algorithm. Then first we divide the greater number with the smaller number. The quotient will be 2 and remainder will be 614. Then for this produced quotient 2, in this case, we multiply this number with S and T in this lower line. So 2 times 0 is 0, 2 times 1 is 2, in that order. And then we subtract this result from the previous value of S and T. So 1 minus 0 is 1, 0 minus 2 is negative 2. Then after that is exactly same format. Now just use, so after this we just be careful. I mean, you have to move this divisor to as a dividend position, and the remainder, you have to use remainder as the divisor in the second level. Then you just do exactly same format. Divide this number with that, quotient is 1 and remainder is that. Then of course multiply 1 with these results on the same line. So 1 times 1 is 1, 1 times negative 2 is negative 2. Then subtract these two numbers from one previous line. So 0 minus 1 is going to be negative 1, and 1 minus negative 2 becomes 3. Now move this divisor to dividend position and remainder to divisor position. So like that. Then the quotient is 1, remainder is that. So quotient times that number, quotient times the t is that 1. Then subtract, be careful, subtract these results from 1 and negative 2. It will giving us 2 and negative 5. So you just keep doing that procedures until you hit the remainder becomes 0. Then when you get that, of course you have to stop there, right? Whenever you get it, don't do any further. Then 1 above of that remainder. So in this case is 1. Oh, I just point out this one, but same thing. And that will be the greatest common divisor of these two given numbers originally. And the linear combination, one possible linear combination of these two numbers to get that greatest common divisor is using these two numbers. So you have to match one by one, right? So the result of S must match with the larger number, and result of T must matching with the divisor of the smaller number in this algorithm. So if you multiply negative 258 with 2632 plus this number with that, definitely the result must be 1, which is the greatest common divisor of these two numbers.